Everything we have built so far lives on one machine. Chapter 5 changes that. We are going to connect our script to the internet, make HTTP request, receive JSON response, extract exactly the data we want, and chain it all together. This is where Bash starts talking to the world. In offensive security, APIs are everywhere. Web application are APIs. Threat intelligence platforms have APIs. Shodan has an API. Aristotle has an API. C2 frameworks communicate over HTTP. Understanding how to make API calls from the command line and fast response is not optional. It's table stakes. An API call is just an HTTP request. Your script sends a message to a server. The server processes it and sends back a response. That's it. Here are the some of the here are the uh, you know how the HTTP request works, how they are formatted, HTTP methods and status code. Know this know this called. So 401 versus 403 trips people up in status code. 401 means you are not logged in at all. 403 means you are logged in but you do not have permission. In offensive security, that distinction matters. 403 tells you the resource exists and you are being denied, which is useful in first is a call request, and the some call request flags you should know, like -s, which is for silent mode, and capital S, which is silent mode, but it will show an error if there is any. Always use -s in script. Use -s, small s, and capital S to stay silent but still see errors. The best of both worlds. Then is -v, which is a verbose debugging. Now we will see the okay. So let this curl process. Now we will see the HTTP method with curl. So it will give the we will do with the get output. Then there is a post with JSON body. So it's something like this. Let me clearly so you can see properly. Next, I will show you on the screen above the authentication pattern, which have better token or basic auth or API key in headers. Next, uh, going forward, we will be checking the HTTP status. It will get this code only gets the HTTP status code. In this, there is a script which will check the status code before processing. So I will just run the script on the command line. Okay, so this will show the like if it succeed, it will show the success, and if it not, it won't. Next is saying output and following redirects. So saving the output, we will use the -o flag. What it will do is it will just store the output on the O. Now If you want to follow the redirect, you will use hyphen s and capital L. Okay. So let me see the output of the GitHub user.json, which is stored. Okay. Sorry, not output if it is created or not. And if you want to see, you obviously you can see that too. It will look like this. Going forward, what is JSON and why base needs JQ? So JSON is a JavaScript object notation, the standard format for API responses. Everything is a key value base in curly braces. That means in curly braces. Bash has no built-in JSON parser. Grep and AWK on JSON quickly hits edge cases. The right tool is JQ. So just install the JQ while running the sudo apt. You have to run on your Ubuntu server, not on the SSH. Check the version of JQ. Run the JQ version. My version is 1.7, and it will show you if it's installed or not. If it's pre-installed, you don't need to install or update. You can use that or same version. So as a basic extraction, we start with I will go with uh, doing the basic extraction. See the name, you can see the name, lower X, role admin, check you got name. It's with quotes, and there is also with no quotes. See, so I given the output with quotes in Clover X, and in next step we didn't use the uh, uh, quotes with Clover X. Next is the multiple field and nested axis. So extracting multiple fields as object, we will use this format, JQ, we use JQ for extracting the multiple fields as object. You can see that this is Linus, Torvalds, and Repo 11. So it did extract name and repos of the Tarvalos. It's a Tarvalo, no? Okay. Next is nested dot chaining. Same thing, but with dot chaining. Now we use the array, like selecting a particular name or selecting everything from the curl, and or select filter. We will use the filter select to filter out. First is the particular index number array. Let's see. Okay, so it did remove gave you the repo name, first repo name. It's 159 replay. Now every repo names, like you can see every other repo names inside the repos Torvalds, sorry, right? And then now we will use the select filter, means filtering with select. Next is a null fallback. Uh, it will show you if there is, it will tell you rather than give error that there is nothing inside name bio. Okay. So we will now capture the API data. First, we will create a SSH nano. Let's create nano and API demo.sh. And this is the code. Make the API call once and store the response. Never make the same API call twice. So we'll create the API variable. Have run the curl sss at api.github.com. We will store it in name API response name, then public repos echo API response aq.location, you know, everything. And we will echo the output of this JSON, captured JSON. So running the API. Okay. So never make the same API call while it's low and some API rate limits. Look over API result safely. So I will just show you here. Okay, so while IFS is equal to read, hyphen R is the safe way to loop over multiple line out, and IFS equal to prevents white space stripping. Hyphen R prevents backslash interruption. Then we will use a chaining API call. For that, I will edit my API demo again. Sorry. Okay, here is the chaining API calls. How it will run. We have chained the API call, eponyms, and then we'll build a JSON safely with the JQ-N. Okay, and save it. So JQ-N, or sorry, means okay. So JQ-N means null input and build from scratch. Hyphen ARG passes base variables as safe JSON strings. This is the correct way to build JSON in shell script. Let let us run the script. Let's clear for one dash what was the API okay, so here is the output. Okay, so now going on to the curl security relevant flags. I will show you on the screen some commands which are relevant for security relevant flags. First is proxy routing. Uh, you can see it's a HTTP proxy buffshoot routing. Then there is a SOC S5 proxy. Then TLS. Then third one is TLS. Skip cert verification, which will skip this cert verification. Then cookie-based session handling. There are two different. Okay. Then timeouts and retries. And then override user agent. Also, there is a get your public IP. I will show you some JP advanced patterns on the screen. You can try them out on your own. Uh, just for the information, the first command lists all the keys in an object. Second command used count element in an array. And third command will show you the three most starred repos, top three most starred repos. Going with our exercise 8, I will give you 5-second pause, read the exercise, and we will solve in some time. So going with our the exercise, we will create a weather.sh which will ask the user to enter a city and we'll use call to fetch it, and it will fire into JP-R to extract the current condition and save the result to variable called temporary, and it will print the current temperature city, uh, in temperature in the city, and in the actual temperature. So a real API call live data 12 lines of bits. That's a curl and JP combined. So we will run this command. Let's give the permission. Let's take as a message. So the, let's enter the city. I will use June 0. There is no output, and there is a, I think there is some error, and let's handle the error. We will update the weather dot message. Okay, it's now enters and the temperature of, as you can see there is the temperature of 16 degree. When we let's see, mm, also veg curry. Mhm. Okay, so I think the New York City is locked from 1 to 10 people. For the chapter 6, security best practices. We've been writing script that work. Now we are going to make sure they don't leak credentials, don't execute arbitrary commands from user input, and don't leave sensitive data all over the file system. Secret management, command injection prevention, and safe time file handling. This chapter is essential. A script that works but has security holes is worse than no script at all. Okay, so for your task extension challenge, modify weather.sh to accept the city as a command line argument. Use $1 instead of using read. If no argument is provided, fall back to asking the user. Let combine argument handling from chapter 4 with what we built today. Drop your solution in the command. Drop your solution in the comments, not in the command. Subscribe for chapter 6. See you there.